Today we're doing 6.6 and we're going to be integrating exponential functions, okay? I put integrating e here, okay? I'm integrating exponential functions. Okay, so first thing before we start integrating these exponential functions is there's some things you need to make sure you know about e to the x, okay? So first thing is, what does the graph look like? Okay, the graph looks something like this. Now it's not going to be perfect, but I know it looks something similar to that. Okay, so if you just remember that graph, and the way I always do it with you guys in class is I say E looks like this, right? And it crosses at the 1 at this point, right? That's why I put a little line right there, because that's the important point to remember, right there. Okay, so there's only one value on here that you must know. E to the 0 is equal to 1, okay? E to the 0 is 1. Now the next question is, when does e to the x equal 0? Okay, well if you look at this graph, when could this function ever equal 0? A y value of 0. And I would hope you'd say it doesn't happen, it never happens, okay? E to the x can never equal 0. And there's a lot of times in this class you might have something like e to the x, like 2x or something times x plus 3 equals 0, and you got to figure out when it equals 0, and then you're setting like e to the 2x equal to 0, and you're setting this equal to 0, and you would say, oh well, this is easy, this one's negative 3, and then you come to me and you go, I can't figure out when e to the 2x equals 0. Well, that's because it never equals 0. This doesn't happen. Okay, so that's a non-result. It doesn't give you an answer. The only answer to this is negative 3. Okay, another thing that you need to know about e to the x is that e to the anything, in this case I put negative 2.3, I was just picking a random number. E to the anything, is it going to be positive or negative? It shouldn't say it should say or. Sorry. So is it going to be positive or negative? And the answer is positive. E to the anything is positive, okay? Unless they throw a negative on the front here, then it's going to make everything negative. But e to the anything is positive, okay? And that's everything you need to know about e going into this PowerPoint or this worksheet. Now let's show you how to do some of these. Okay, first thing is to know is the integral of e to the x is e to the x. Okay, it's weird. The integral of it is the same thing. And if you just look at the graph, okay, you can kind of tell something weird is happening here. At every point, the y value, like in this case, the y value is the same as the slope. Okay, so the y value is the same as the slope everywhere on this graph, which means the derivative of it is itself, or the integral of it is itself. And you guys learned that when you took the derivative of e to the x, the derivative of e to the x is e to the x. So the opposite, going backwards, would be the same, okay? So the integral of e to the x is e to the x. Now sometimes they're going to throw other stuff up here, which like let's say they throw 5x or something. The integral of e to the 5x is not e to the 5x, okay? That's not true, okay? So if they ever throw something else up there like 5x, you're going to have to do u substitution. And so you know integral of e to the u is e to the u, okay? So integral of e to the u is e to the u. So let's go through this, yeah? So one thing that I hope you just figured out is that if you ever have e to the anything that's not just x, it's going to be u substitution. And since it's u substitution, you know the steps. It's the same steps as always. Okay, you're going to find u, you're going to find du, you're going to find dx. Those are the first 3 steps. And then you're going to substitute in the u, take the integral, plug u back in there, right? Okay, so first thing here, what is u? Whatever the exponent is the u. So 3x squared is my u. Okay, the derivative of that is going to be 6x dx. Okay, now we're going to solve for dx, which would make this du over 6x. Okay, now we substitute in. So the integral, okay, 4x is just going to stay the same. E to the u now, because I called this whole thing u. That's why it's u. And we're not going to have dx anymore. It's going to be du over 6x. And remember, this thing is really over this, okay? It's over the whole thing. You can think of that line over everything. Okay, which means the x's can cancel, and the 4 and the 6 will simplify to 2 over 3, yeah? So this can be rewritten as 2 e to the u over 3 du, okay? Because I canceled the x's, I simplified the 4 over 6 to be 2 over 3, and the e to the u I didn't do anything with, so it just stays up there. Okay, now I can take the integral. The integral of e to the u is e to the u. The 2/3 just come with it, okay? So we're going to have 2/3 e to the u plus c. Okay, now this is so easy that people are going to get confused. It stays the same. Yes, I know. We didn't boost and divide. We didn't do any of that. The derivative of e to the u is e to the u, right? I mean, the derivative of e to the x is e to the x. So that means the same thing here. We did the stuff with the u, and the integral of e to the u is e to the u. Now, do the last step here. Don't forget to plug in x back into here. So it's going to be 2e to the 3x squared over 3 plus c. And that's my answer right there. Okay, now let's come over here. Now this is e to the something else, okay? Is not e to the x, so that's your u sub, yeah? This is our u. So let's do this. It's going to be u is equal to, and I got to find my du and I got to find my dx, right? It's going to have all of that. Okay, so it's going to be x squared plus 3x minus 5. Du is going to be 2x plus 3 dx. And then dx is going to be du over 2x plus 3 because I divided by this thing right here to solve for dx. Okay, now it's substitution. I have the integral of 2x plus 3 e to the u. That was the whole reason I did all that, right? And then this is going to be my dx. Du over 2x plus 3. Now I hope you see right here, this cancels with that. And we're left with the integral of e to the u du. And the integral of e to the u, it's very easy. It's the same thing, e to the u plus c. Okay, and don't forget to switch that u back to being x's. So it's e to the x squared plus 3x minus 5 plus c. And there's my answer, right there. Okay, I believe I got a couple more problems for you guys to practice on. Guys, so let's do this one now. First thing is, this is an e to the something that's not x. So I already know right from the start this is u sub, and this is going to be my u, because that's my exponent of e. It needs to be just u, or just x, okay, because that's how we do the integral. So we know u is going to be 2 over x squared. Okay, now remember you find du, you find dx after that. I chose this one because it would be a little different than the other ones. If you're going to take the derivative of this, remember you're going to need to rewrite it. That thing needs to move to the top so we can take the derivative. Yeah, that's how we take the derivative, is you got to rewrite it so the variable is on the numerator. Okay, now the derivative of that is going to be negative 4 x to the, we subtract 1, negative 3, right? We write dx at the end of it. Now I can't leave this with a negative exponent. I want to rewrite it, so I'm going to rewrite this as negative 4 over x cubed dx. Okay, now here's where some people are going to get a little confused here, because we now need to solve for dx, right? So here, I'm going to do this over here. What I have is I have du is equal to negative 4 over x cubed dx, right? Now, don't get confused here. This dx, I've been writing it off to the side, but it really is just part of the numerator, okay? So I need to solve for dx. So let's first multiply this over there. It's going to give us x cubed du is equal to negative 4 dx. And then we're just going to divide by negative 4, and we're going to get dx is equal to x cubed du over negative 4. And that's what dx is equal to. So I can write that over here, x cubed du all over negative 4. Okay. Now I got those three things. Those are my first three steps. Next step is substitute all this stuff into here. That was the whole reason of doing it. So I have the integral of e to the u over 4x cubed. And then it's not going to be dx anymore, but it's going to be this, which is going to be x cubed du all over negative 4. Now remember what I was just telling you. Really, this is all one big fraction, okay? I've been writing the du over to the side, but really it's on the numerator, okay? Don't get confused. Now I can simplify. X cubes cancel out with x cubes here, and we're left with the integral of e to the u all over 4 times negative 4 is going to be negative 16, and then du is what I'm writing on the side, yeah? Okay, so I could have written it on top of the fraction, that's not a big deal, but I'm just writing it on the side because that's how we've been writing everything. The integral of e to the u is the same thing, and the constant's just going to stay there, yeah? So it's going to be e to the u over negative 16 plus c. That's the integral of it. Now remember, we don't want that u there, we want it in terms of x. So we're going to write e to the u is 2 over x squared over negative 16 plus c. And that's going to be your integral. That's your answer. Okay, I believe that's all of them. Good luck on the worksheet.